This conference will now be recorded.
Good evening, all. We are going to start our session today. So, today we are going to learn a new, we are going to start a new chapter, that is alternating current. Okay. So, let us first have a introductory discussion about alternating current, like what is the use and all those things. See, nowadays in our modern society, we cannot think of a, a second without electric current, etc. So, in our home appliances and all, see, the power is required, and that power comes as an alternating voltage. Okay, comes as an alternating voltage, and that voltage creates an alternating current. So, what is alternating current? We'll define formally in our next transparency. Before that, we need to know a few advantages of AC signal. See, nowadays many devices are there which runs only in AC. Not only that, when power transmission is done from very far power station, so you can see this, it is coming from very far to your home. Okay, so this voltage or the current what is transmitted through this high tension wires and all, it is actually in the form of AC. Okay, in the form of AC voltage. Okay, this is because it has certain advantages. AC voltage can be converted easily from one value to the other. This can be done by transformer. We'll learn at the end of this chapter what is transformer. Okay, by using transformer. So if you have suppose 100-volt uh, AC signal, you can convert it to 1000-volt also by using step up transformer. Or if it is 1000-volt, you can do the reverse way also. Can you can reduce it to 100 also. Okay, so it can either increase to some value or decrease it to some value. It can be done easily by using transformer, step up and step down transformers. And this is easy to do with AC signals, not with the DC. Other than that, another advantage of using AC is, see, during this transmission itself, uh, see, we have already learned that there is joule heat loss. So there will be huge power loss if you use DC instead of AC. So in case of AC, power loss is less. Okay. So economically, power can be transmitted from one place to other place of 1,000 miles maybe. Okay, so this is done by AC only. So with this brief introduction, let us learn what is uh, okay. So look, we have so far learned DC sources, and we generally denote with positive and negative, like DC voltages or DC sources like this. Okay, positive terminal and negative terminal like this. But now AC sources will be denoting by this. The see, this is a kind of uh, sine curve. So this is the symbolic representation of AC sources. So this is what we'll be using for alternating current or voltage. Now let us learn what is formally called, or we'll define what is DC current and what is AC current. So not only current, any signal, if it is flowing with a constant magnitude in the same direction, constant magnitude with the same direction, okay, and whatever time you measure, the magnitude and the direction of that signal is in the same, like at the same. Okay, so that is actually direct current. And what is alternating current or alternating signal? So alternating signal is a signal whose magnitude changes with time. Not only magnitude, even the direction also reverses periodically. Let us see the symbolic representation, and maybe graphically we'll see here. Look, a voltage or current also can be having the same variation. Okay, so in general we can say AC signal and DC signal. So DC signal, you can see this is a signal versus time curve. Okay, and you can see this curve. See, this is parallel to the time axis. That means it is having a constant value. If I say this has some, if it is a voltage, some 12 volt, so it is remaining 12 volt forever. As you progress in direction of time, it doesn't change. Okay, but on the other hand, you look here, this is showing a sinusoidal variation or sine. Okay, so it this can be okay, so this is a sine curve, right? So if it is a voltage, suppose this voltage can be represented as V0 sine omega t. Okay, this is how you can write this or represent uh, this AC current or alternating current or voltage or whatever. That means AC signals you can represent with sinusoidal variation. And you can see here that at each instant of time it is changing its value. So this is time axis. So you see this is one, so some second, this time may be second in second units. So if this is 10 second, then 30 second, like that. If you go time to time, it is changing its value. Look here. Okay, at some time it reaches to this maximum value, and then again, see here, again it becomes 0, and then progresses towards other direction. See, this is again increasing in the other direction, and here it is maximum in the other direction. Okay, again from this point, you look, as time progresses, it decreases to 0. So this is how time to time it changes its value. So not all, so this is value in the sense the magnitude of the signal. If it is a voltage, then voltage signal. If it is current, then current. Current also can be written as I is equal to I0 sine of omega t. So I am writing here sine, since my curve is sine. Even you can do it, you can represent an AC signal with cosine function also. So V is equal to V0 cos omega t. Okay, even sin, even I can also be written as I0 cos of omega t. So this is how also you can. So I mean to say that you can use either cosine or sine function to represent any AC signal. Okay, so you can see then the direct signal or direct current. I'll just take specify now as current. So direct current does not change its direction as well as the motion with time. Sorry, magnitude with time. But alternating current changes its magnitude with time. At the same time, it reverses its direction periodically. So I have shown here this is called one full cycle. Okay, okay. So I'll just remove this. So you can see full cycle even I have here. So when you start from here, so 0 to it goes up to maximum value, then come to another 0 and come up to here. So you have this is called a full signal. This is called full signal or full scale or full cycle. Full cycle. This is called full cycle. Cycle in the sense it has positive cycle, this one, and it has negative cycle. And you can see that AC signal is perfectly symmetric in both sides. If it is called, if it has maximum plus A value, here it will be maximum in the opposite direction. Maximum value will be minus A, right? So we'll learn few more terms uh, in the next slide. Let us go there and see. So we'll be learning various terms of alternating signal over here. I hope you are able to see my screen properly. If you can see that, uh, see we'll be defining here few terms of AC signal. That is, see, first term is instantaneous. Instantaneous value or instantaneous. Okay, instantaneous value of. Here I have taken suppose current. So current or any AC signal you can think. Okay, so instantaneous value we'll be learning what is called amplitude or peak value. This you have already learned maybe in your 11th standard, but still I'll repeat for your understanding. And then we'll be talking about something average value. What is average value and RMS value? These are few terms we'll be learning here. Look, you can see here this I have taken as sine wave. Here you can see this I have taken. Okay, so in the figure it is written as A. Maybe I'll just, since I'm talking about current over here, I'll not take a general thing. I'll think of uh, the current itself. Okay, I of t is equal to I0. Okay, I0 sine of omega t. So this is my, so this is the mathematical representation of AC signals or AC current over here. So whenever I write this kind of equation, you need to know what is what. Okay, which term is what. So this term I of t as a function of t, this term is actually called instantaneous value. Okay, that means this value is telling you what is the value of current at each instant. At each instant, what is the value of current at each instant? See, that means here you look, if I just say this value, this value this value, okay, this value. These are having different values of current. See this one, this one. These are the values of current, and at this point there is the maximum value. So this I of t in the left hand side is telling you the instantaneous value of current. That means this equation gives you the value of current at any time you would like to know the value of the current. Okay. All right. So this is instantaneous value of the current. Then would like to know what is peak value or amplitude. See, amplitude you might be knowing from your 11th standard knowledge that amplitude of any wave is the maximum value it attains in both sides. Okay, both side in the sense, since it is symmetric sinusoidal wave, both in the positive cycle and negative cycle. Okay, the maximum value it attains in both cycles. Okay, or simply you can say the maximum value any wave attains is called the amplitude. Okay, here it is written as a max. I can just tell you this as I max or I0. We have denoted as I0. So the value peak to peak value, you look this, sorry, not peak to peak value, this is called amplitude. Okay, amplitude. Okay, or sometime it is called peak value also, amplitude or peak value. Sometime we will be using a phrase peak to peak. Peak to peak means from here to here. You look, this is peak to peak value. This is negative peak here, and here positive peak here. So this value is called peak to peak value. That means you have peak to peak value. Uh, Magnitude of the peak to peak value is 2 into amplitude, 2 twice of a max. Okay, peak to peak value is this twice of a max or amplitude 2I0. Peak to peak value. Okay, peak to peak peak value means 2I0. So if you want to know what is the amplitude, then you have to divide with 2. Peak to peak by 2 is amplitude. Okay, amplitude. Peak to peak value divided by 2 will be amplitude of the signal. Okay, so we have learned what is instantaneous value, what is amplitude of the signal. So this looks very messy. I'm just removing some of the things so that things will be clear to you. Okay, uh, now see this average value and RMS value will be learning. In fact, we can learn better in like while discussing various circuits with AC signal. But just before that, I'll just mention few things about these two terms. See, when I talk about average value for AC signal, you look here. This has plus value plus A, and this has negative value. So since it is a sinusoidal or sine curve, and it is symmetric, very much symmetric. If you want to calculate average, simply you want to take average. See, in a full cycle, what you get A plus A minus A divided by 2. So you will get 0. So we cannot take a full cycle average simply like this. Then you will get average value at 0. Okay. That's why when we talk about average value of any signal, we don't take full cycle average. We take generally half cycle average. And see, we'll be defining average value and instantaneous value here. Yes. So see, as I told, average means, see, if you take average in full cycle, it is going to give you 0. But generally average value of current or mean value of current is defined, both are same actually, mean or average is same, is defined in half cycle in case of AC signals, because it is symmetric. If you take average in a full cycle, it will give you 0. So it is defined in half cycle. So what is the average current? Suppose if I want to define a current, average current, see, definition is saying that uh, so I'll write average value of current is defined as the value of direct current which sends which sends the same amount of charges as, so same amount of charges in a circuit as AC current does in half cycle. Okay, half cycle. I'll define this, okay, mathematically here. So I'll just tell you the definition once again. The average value of current is defined as the value of DC current, defined as the value of DC current which can send the amount of charge, the same amount of charge as DC current, sorry, AC current can do in half cycle. Okay, that means if I have, see, current as I is equal to I0, this is obviously function of time, sine omega t. Okay, so suppose in any time dt, how much current charge it can flow, it can flow or it can send a charge in a circuit, that is dq. So in dt time, it can send a current, sorry, charges of it dt. Okay, it dt. So let us see what is the total charge in half cycle. Okay, total charge in half cycle. Then we can take uh, average in half cycle to get the current or the amount of the current. Okay, let us see what happens here. So if I just want to calculate the current, the total charge in half cycle, so integration 0 to t by 2 half cycle. Okay, generally time period or a full cycle is having like it takes time, t, capital T is the time period, you might be knowing. uh, so it is it dt. All right, so I'll put here this thing, 0 to t by 2 I0 sine omega t dt. Okay, so this can be again expressed in terms of okay, so if we just integrate it, what we get, I'm not just doing the integration here, you can just do by yourself. I'll just write the value that the total current will total charge will get in half cycle is I0. This is a very simple integration you can do by yourself and see. It will be I0 t by pi. Okay. Now if I want to get current, then you can write uh, average value of average value of the current. If you want to see, this will be actually, if I write current, so it will be I0 by pi. And if you, so this is actually, this is for half cycle, so this is charge. So average current will be charged by T by 2. So finally, okay, so I'll just use this portion also. Let us see. We have got a charge is equal to I0 T by pi. So this is for half cycle. So if you want to get the current in the half cycle or average current, so what you can do is you can write this by 2. Okay. So if you do this, so what you get is I0 T, and this is 2I0. This is T into pi. So T goes off. So you get is 2I0 by pi. And you look, this value will be 0.637 into I0. So average value, you can see here, I'll just clean this portion. See, the average value is this is the line, this is the average value, whereas this is the maximum value. Okay, average value, then average value or mean value is 0.637 into I0. This is the relationship between average value. Obviously, this is defined in half cycle. So average value of the current is, see, sometime in your question it will be given 63 percentage of, so nearly 63 percentage of I0. Okay, 63 percentage of, so average value is nearly 63 percentage of I0. Okay, this is the average value. So RMS value will be defining later. So you can understand that there are few terms which are very important here to learn. One is what is instantaneous value, what is maximum value, and what is average value, what is RMS value. RMS value will be defining in the due courses, like when we will be taking various circuits, that time we'll be defining RMS value. Okay. All right. So now let us learn few terms again here related to wave. Okay, few terms we'll be learning already. I was talking about time period. So if this is time axis, or sometime it will be written omega t, and this is your, this is a sine curve. Obviously, you can see that here. Okay, and this is the signal. Suppose I take this as current, which is sine omega t, and having I0 sine omega t. This variation. Okay, this is the thing. Now, see, I start from here, then goes to maximum, then goes to again 0, and goes to the minimum value or the maximum in the opposite side or reverse side, again goes back to 0. This will actually give you a full cycle. That means in a full cycle there will be a crest. and a trough. Okay, so there will be crest and trough. Or okay, so these are the things. And in this case, the time it takes to complete a full cycle, this is a full cycle. So it goes from 0 to maximum, then goes come back to 0, and then goes to maximum in the other side, and again comes back to 0. So this is actually a full cycle. This is a full cycle. Okay, this is a full cycle. And the length, if you go lengthwise, the distance is traveled in a full cycle is called actually wavelength. Okay, so this is actually full cycle. So the length of full cycle, this is called wavelength, which is denoted by lambda. Okay, sometimes people go crest to crest. This also can be defined as lambda. Okay, or trough to trough. Okay, so whatever possible. So at least you need to know that one full cycle has to be completed. Okay, full cycle has to be completed. So this is lambda. Then this will give you half lambda, lambda by 2, and this is actually quarter of lambda. Okay, quarter of lambda. Okay, this is, so lambda is called wavelength. Wavelength. Okay, lambda is called wavelength. Now the time it takes to complete a full cycle is called time period, denoted by capital T. Time period, it is denoted by capital T. Okay, so you have learned what is lambda or wavelength, what is important topic or point here is called phase. Now let us see what is phase here. So you have already learned. I'm just recapping these things because these are needed for uh, this chapter to learn well. See, I have a signal. So if I want to know what is the phase at each point, okay, what is the phase at it, or maybe I'll say what is the relation between uh, the particle over here and here, okay, or maybe between here and here. So there is something called phase which will give you, actually phase will give you the complete information about the state of the system, complete information of the state of the system, or state of your vibration. Okay, so look here, these may be equivalent point, but they have different phases. Okay, different phases. So I'll just uh, see, I'll just take this as a circle. If I start from here, suppose there is a see, we'll be obviously learning a rotating vector. See, this kind of uh, sinusoidal signal can be generated by rotating a vector anti-clockwise direction. This is called rotating vector method. So if I have an angle, uh, suppose your omega t here, omega t plus theta, this one is theta, so theta can go from, theta is 0 over here, so theta can go all the way up to 360 degree. Okay, this is the quantity. Suppose this is a current, so now I can write this as I0. This is the magnitude of the current. Okay, and it can, sorry, length of this will give you the magnitude, and instantaneous value will be obtained from here. Okay, like that. We'll just discuss that also, but here what I'm trying to say is the phase. So I'll not go with this now. We'll just, so what I was telling you, that the angle can be calculated from here, starting from here, theta is equal to 0, then theta here 90 degree. Okay, in terms of degree, this is 180 degree, and this is your 270 degree, and this is 360 degree or 0 degree. Okay, so you look, if I just have a quantity which is varying from 0 to, see, at theta is equal to 0, if I think this is theta, so at here the quantity has a 0 value, then it is having a value here, this much, then this much, and at 90 degree, see, look, this is 90 degree, so this is 0 degree, this is 90 degree, it has a maximum value over here. Okay, maximum value. Now it goes, see, in the opposite direction. Now at 180 degree, look here, again it has a 0 value. Okay, because the projection of this vector will be 0 over here. Okay, so it has 180 degree, again 0 value. You go to 270 degree, this is 270 degree, this is again a negative value. If I take this as +1, positive value, this is negative value for a sine curve. Okay, with having one amplitude. So now you go back to here, theta is equal to 360 degree, again it has a 0 value. So this is how you can see, you can define the phase. So this is actually 0 degree phase, this point is 90 degree. Okay, this is 180 degree phase. Okay, 180 degree phase, then this is 270 degree, then this is 360 degree. Then again, when the another signal starts, so it will start from here, so 360 degree to here 90 degree, so it will be 450 degree, then it will be something here again, so 360 plus 180 degree here, then 360 degree plus 270 here, so like that it will come here 2 into 360 degree, that means 372 degree here at this point. Okay, this is how phase goes. This is actually very simple way to represent. Now you look here, I'll just give you certain names. See, I'll give A, this is B, this is C, this is D, this is E, this is F, suppose, this is G. Okay, maybe another point I'll take GH here. Okay, now we have to say, see, this A and this C, what is the, are they in same phase? Are these same phase, A and C? A and C? No, these are not in same phase, because see, at A the signal is increasing, going up, but at C signal is going down. So they are not in the same phase. Okay. Again, if I say this uh, O and D, okay, O and D are not in same phase, whereas O and G, they are in same phase, because see, the wave is going upwards. Here also going is upward. Wave is going upward. If I take this this B, and this H, they are in same phase. Okay, they are in same phase. At the same time, you look this and this, they are called actually 180 degree away from each other. This is 90, again another 90 is here. Okay, so they are 180 degree out of phase. So this point B and F, they are 180 degree out of phase. Okay, you might have learned again further detail uh, while we'll be discussing various circuits. That time we'll show you. So we'll see, this is with different points are having different phases for the same wave. But what if I have different waves? Like, how do you know whether they are in phase or not? So if the two waves are having zeros and maximums and minimas, maximas and minimas at the same point. Look at, okay, so this can be, so I had shown you uh, in terms of degree, but you can go with even radian also. So 0 radian here, here maybe pi by 2, here pi, here actually 3 pi by 2, then here it will be 2 pi. So you can go with that also in terms of radian. So here in this signal you look, this is these two signals, one is voltage and another one is current. We'll see in case of resistive circuit, both are in the same phase. How do we know both are in same phase? Because their zeros and maximas and minimas, they are occurring at the same place. That's why these are the waves are actually, so here voltage and current V and they are in same phase. Same phase. So these are the terms which we need to learn. That's why today's class is very introductory class. Next day onwards, we will take the pure AC circuit topics, whatever you have in your textbook. Okay. So then look this one. So this is sine wave and this is cosine wave. See, you can see this when your sine wave has 0 over here, cosine wave has 9 as a maximum value over here. Or if I start from here, you look, uh, yeah. So when you have for the cosine wave, you have 0. For the sine wave, you have 90. So these two are actually called 90 degree, 90 degree or pi by 2 phase, out of phase, out of phase. So out of phase. So the signal sign here is actually, so the cosine means it is actually starting from minus pi by 2. You can think of that. So we can say that if this is see if this has uh, sin omega t, this is cos omega t obviously. So this is actually, see, sin omega t can be written, sorry, cos omega t can be written as, cos omega t can be written as sin omega t minus pi by 2. Okay. So this is what we can write. So that's why, see, cos omega t, that means wave this wave we should say lagging, okay, behind by pi by 2 phase, okay, phase. So this is how we have to term, okay. So if, see, then in the other way I can say sine wave, this wave is leading, leading, we can say that sine wave is leading, one is lagging, another one is leading, okay, leading by, leading over this wave cosine by 90 degree or pi by 2 phase, leading by this, okay. One will be called as lagging, another one will be called as leading wave, okay. So this is how we have to term, okay. Now it is already 7 o'clock. If you have some other classes, I may stop it here, or if you don't have any issue, then maybe I can go another 5 minutes. Shall you stop it here and then start? Maybe if I start the next topic, will take more than 5 minutes, I guess. So I think I'll stop it here for today. Next day onwards, we'll start our textbook stuff. Okay, this was very introductory class today. So Deepa and Guna, if you have any doubt, you can ask me another 5 minutes in this AC signal. So many people used to tell that they have lot of confusion in AC signal. What is amplitude? What is uh, instantaneous values, etc. Okay. So if you have such any such doubts, you can ask me now. I can clarify you here, or else we'll in the class. Next day onwards, we'll start the textbook topics, like various circuits will be taking first, resistive circuits. I'll just show you what we have in this chapter. See, first you have, see, we have learned what is called AC signal, etc. Now, this AC signal, if we just apply to a resistor, what happens? Then, if we apply AC signal to an inductor, what happens to the current and voltage? What is the phase relationship? Then, if we apply the AC signal to a capacitor, then what happens to the current and voltage? What is the phase relationship? Okay. Then we will see L and C combination, then LCR combination. In that, if we apply AC signal, what happens? So this is how we'll go in this chapter. This very interesting chapter. Uh, so do you have any doubt over here, Deepa? Guna? Okay, so I hope you have understood. Since you are not talking anything, I'll think that you have already understood that what I have discussed today. So I'll stop it here. We'll meet again on Wednesday. That day we'll discuss in detail when we apply AC signal to a resistor, what happens to the current and voltage. And maybe Phasor diagram we'll learn that day. What is Phasor diagram and how we can define, or we can produce an AC signal by rotating vector method. So with this, I'll stop it here today. I'll see you on Wednesday.